All right, good morning, everybody.
Morning.
We don't need no two's complement.
So it's been a while, but can you remind me kind of what classes and objects are again? Because it's been a while and I've been busy with the classes.
Classes are like structures, and objects are like variables.
So that's right, isn't it? Like so, objects can be inside classes that can I create some sort of method, correct?
Yeah, so we let's
Okay.
go back to, let's see. So let's take a look at this. I could have just done parent directory. Let's go up to first examples. Oh, no, let's go to rectangle and big number. So here's an example of a class. The class name is rectangle, right? So that's like a structure in C. It's a thing that contains variables and code. And so it's got a height, and it's got a width, and it's got a method for finding an area and a method for finding a perimeter. And so when we look at using that, we can say rectangle A, B, C. Okay, rectangle is a class. This is like saying struct rectangle in C. That's a class. It's a description of this thing that will contain, height and width and areas and so on. A is an object, right? It's an instance of a rectangle. And when we use the new keyword, we construct an instance of a rectangle, and we save that instance in this object called A. So the object is the actual instance of the class, which is kind of like the blueprint for something. All right, other questions? So thank you everybody for being here. I know it's a snow day, and I guess classes were only canceled until 10. But I know some people have lost power, and there's lots of tree branches falling. I just stepped outside, and I heard one crack in the distance, and I had one fall across the street, and so people are losing power and such, and public schools are closed today for the most part. So
Yeah,
and just
my university is closed for the day.
okay, cool. Which university?
Washington State University.
Okay. Oh, cool. Didn't know that. All right. So glad people could be here, and if you weren't here, that's okay. But I'll post the recording after class, so you can catch it there. Cool. Other questions? I have some like awesome hot chocolate here. All right. I came from New York State, and there were two weather guarantees. One, it would always snow by Thanksgiving, and two, almost every year it would snow right around Easter. And we'd usually start getting into spring-like weather in April, but there'd always be one last hurrah, which would be a snowstorm right around Easter. And so this has kind of been New York weather this year, which is interesting. All right, let's talk about PA1A. So PA1A is graded for those who submitted it as of yesterday morning. I haven't looked today for 4 slip day submissions, or 3. Good job on PA1A. So I was totally thrilled as I was grading these. I was expecting that at least some number of people would get into all kinds of tangled issues with with trying to roll this thing out in Java, and almost everybody nailed this perfectly, which was great. Even if you had a situation where it felt like, this really wasn't right and a lot of it wasn't working, in most of those cases, it turns out most of the code was exactly what it should be, and there might have been one, stray thing somewhere that was causing issues. So the grades were very good on this assignment, reflecting the fact that most people seem to have been able to code their C version of stacks and queues in Java. And that's great. This was a new assignment I haven't given before, so it was kind of a wild card for me. But so really good job with that. So let me go ahead and show you what I did for PA1A, just for comparison. I will say most people, about half the class actually at least put their name in, but some people didn't even put their name into their code. Some people put in no comments at all. You got to be commenting your code, okay? I didn't take off this time. I will in the future. So make sure you have something in the beginning of each of your files saying what it is, and at least including your name, right? But some kind of synopsis of what this class is. And this will be increasingly important because as we develop larger programs, it's going to involve creating more and more classes, and those classes will be designed by you and will be intended to do certain things, and you've got to document that. So comments are mandatory going forward, which means you'll lose points if there's not good commenting. So class PA1A, and so there's our standard main program. We'll play around with that later on and see exactly what public static void main string bracket means and so on. So make a pair of linked lists, right? And since these are generics, we need to specify in angle brackets what type of thing we're putting in our list. In this case, it was just integers. So here's the declaration of stack, right? It's a linked list of type integers. And in the same line, I'm constructing the linked list of integers and then setting stack equal to that constructed linked list. So I make two lists, one I called stack, one I called queue. And this program is stateful. When we type an integer, it might be that integer goes into a stack, it might be it goes into a queue. When we type the integer, we don't say at that point, do we put this in the stack or the queue? It depends what state the program's in. That's what I mean by stateful. So we have a pair of commands for switching between stack mode and queue mode. So we need to remember what mode we're in. So I used a variable creatively named stack mode to indicate if we're in stack mode. You can call this whatever you want, but I really suggest you get in the habit of using good variable names. If you call this X, right, that doesn't really tell you when you're writing your code at 3 a.m. 1,000 lines later, what does it mean if X is true? Am I in stack mode or queue mode? Well, you got to go back and look at your notes. If you've got comments, that will help, but some code used a name like temp or X or A, and there were no comments. So how do you know what that means? Well, you're trusting your memory while you're writing this, and that's just asking for confusion. So why not call your flag something like stack mode or in stack mode or mode is stack or something like that? Even calling it mode leaves you with the question of like, well, if mode is true, what does that mean? I'm in a mode. Well, what mode am I in? If I call it queue mode, then I can say, hey, if queue mode, I'm in a queue, right? So take advantage of the fact that you have long variable names available and make things meaningful for yourself. All right, open up a scanner on standard in. I called that input. I could have called it standard in or something like that. printed out a list of legal commands. I threw that in a separate method called usage. And then I print out a prompt, and then here's my main loop. This is while my input still has input available. So by doing this, input has next line, Control D will kick me out of my loop. So ingest the command, right? That's just the next line method on the input object. And then I just went with a bunch of if statements. You can do switches. Switches with strings will work in Java. It will not work in C. But in Java, you can actually do a switch. But I just went with some if methods. So if my command is S, I'm saying, hey, I want to switch to stack mode. So set stack mode to true and show the stack. That's all I got to do for the S command. If the command is Q, I want to enter Q mode. So set stack mode to false. That puts me in Q mode and show the Q. That's all I have to do for the Q command. If the command is an X, the user wants to exit. So say goodbye and just return from the main method. That's all I got to do for the X. The way I'm writing this code, I am dispensing with my required behaviors as quickly as possible. I don't have to come down here to see what else is going to happen if I'm in stack mode. If I'm in stack mode, I'm doing this and this. Done. If the person says Q, I do these things and I'm done. All right. Otherwise, they did not say S or Q or X. There's two possibilities, right? They may have hit the enter key, which says remove something, or they may have typed an integer. All right, so let's see if they just type the enter key, then the command is just equal to quote, quote. So all of this stuff is what happens if the user is trying to remove something. So again, check what mode you're in. If you're in stack mode, see if your stack's empty. If it's not empty, I'm going to pop the stack and I'm going to print out what the pop returned. Otherwise, I'm going to say, hey, the stack's empty. And I'm not going to do a pop. Alright, so that's if you're in stack mode. Otherwise, you're in queue mode, same thing. If the queue is not empty, do the queue remove and print the result. Otherwise, say the queue is empty. Alright, I added a question mark command. If the person types question mark, give them a usage message. Otherwise, it's not a recognized command. We assume it's an integer. So convert that integer to an actual int by using integer.parseInt. Give it a command, get back your number. If you're in stack mode, push it on the stack. If you're in queue mode, insert it in the queue. That's the bottom of my main loop. Print out a prompt and go back up to the top. And everybody had, some version of this. The main programs looked great, so no big surprises there. And then the methods were again, mostly wrappers around existing methods. So to show a stack, I'm passing a stack in here. All I have to do is print TOS and arrow and concatenate the stack to it. To show a queue, same thing. Print out a head, concatenate the queue, and print out the tail. And this concatenation means change the linked list into a string. And what we saw last week was when you change a linked list to a string, you get a pair of square brackets with the elements of the list inside separated by commas. Alright, to do a stack pop, just call the remove first, or the pop method, on the linked list and return that value. So one really important detail here, in this particular main program, when we pop the stack, we want to print it out. But popping the stack means removing the top element from the stack. It does not mean printing it out. Maybe I want to clear the stack in my main program by popping until the stack is empty, and I don't want to print out everything that I popped, right? So the pop method is supposed to remove the top element from the stack and return it. It doesn't say anything about printing it, and if I put a print statement in here, my stack pop is pretty useless, right? It's only good if someone happens to want to print the top of the stack. So how do I pop the stack? Just remove the first element and return it. If the user wants to print that, it's up to the user to print it. So I took off a few points if you're doing things like printing the popped element in here, or printing the removed element in here. All right, how do you push to the stack? Just add first. How do you push to a queue? Add last. How do you tell if the stack's empty? I just call the isEmpty method from the linked list class and return that value. Again, we don't want to print anything in here. Don't print a message saying the stack is empty, because you don't want to know that. If you're reading input from a user and you check for end of file, you wouldn't want the thing you're calling that does that check to automatically print something. Printing is usually in the domain of the caller, the person writing the main program using your methods and your class. So just return a boolean to say if the stack's empty. And in this case, we can just return stack.isEmpty, because this is a boolean. The same thing with queueEmpty. And there's our usage message, and that's pretty much the whole shebang. So a couple of comments that I made on some people's assignments. These were not things that cost points, but they're things to just kind of be aware of. One is that booleans are, a bona fide type. And so if I say something like boolean stack mode, and I want to know somewhere in my code, am I in stack mode? Well, I can do something like if stack mode equals true. But since stack mode itself is a boolean, I could also just say if stack mode. And this will have the same truth value as that. Right? If this is true, true equals true, this will evaluate to true. Well, that's what stack mode was. If stack mode is false, false equals true will be false. This will evaluate to false. Well, that's what stack mode was.
Well, don't you have to assign stack mode in Boolean before you assume that that's true or false?
I'm just showing some code later on. Yeah, something has to give stack mode a value, or this would make no sense.
Okay, I was just making sure.
Yeah, good. So if I want to know if stack mode is false, I could say if stack mode equals false, but I can also do this. I can say if not stack mode. And this will have the exact same truth value as that. Because if stack mode is false, then not stack mode will be true. So think like, CSE223 booleans. These things work like propositional variables. And so you might see things like this. Let's see, if flag equals true, return true, else return false. So I'll see code fragments like this sometimes in people's programs. What's a simpler way you could write that? You could do that. What's a simpler version of this block of logic? If flag is true, what is this block going to return?
It should return true.
Yeah, and if flag is false, what's it going to return?
False.
Right, so it's going to return exactly the same value as flag has. So why not just say return flag? And that'll do exactly the same thing as this. And once you've made that connection and you're used to writing this, now if you see this in your code, you're going to understand exactly what it's doing. Whereas if you see this, you have to take a little side trip mentally to to parse this out and say, if flag's true, it's going to do this and so on, right? But if you understand this, you know, oh, this function is just returning, you know, whatever the value of flag is. So those are just things to keep in mind, right? This is not wrong. It marginally might take a little bit more time. Who cares, right? But it's not as clear as this once you understand, you know, why this is equivalent to this. If this doesn't make sense, do this, right? If this is the most clear way to write it, write that. But keep in mind you could also write it like this. Keep in mind that you could write this like that. And come back to those now and then, and you can move towards, you know, doing things like that or that or that. And it's another way to sort of kind of streamline our thinking of our code, maybe. All right. Didn't see a lot of other things to comment on, so I put a lot of feedback on some of the assignments. And you may have gotten 100, but you still have a few paragraphs of feedback. So make sure you look at the feedback. It's just kind of things like this, things to think about, general comments, stuff like that. Again, not necessarily something that's wrong, just something to think about and consider going forward. The other thing I want to mention, though, is... one thing I saw a few people do is this business of mode, right? So I made mode just a variable inside my main method, right? And in my main method, I'm parsing my commands, and if I see an S, I'll set mode to be true. If I see a Q, I'll set mode to be false. And then I use mode throughout here to decide, you know, what am I popping from or removing from, and so on. I would not want to do something like make mode some kind of global variable and manipulate that from some other method. In other words, we want our interface to our stacks and queues to follow that specification we had in the assignment as exactly as possible. Which means we don't want to require, for example, that the person defines a global variable called stack mode, and that, you know, one of these functions like pop or something would affect that. And this will become clear with PA1B, which we're going to go over next. We want this nice clean separation between the user code and the implementation of whatever data structure we're making. So here's the main method, for example, that calls methods inside, you know, this class declaration. We don't want the things in this class to be directly manipulating local variables in the main program, and we generally don't want the main program manipulating things set up in the class. We want this firewall there, right? So abstract data types again. And so we'll see that more clearly when we talk about 1B. Any other questions or comments on 1A first?
Can we talk about the ODP 301 that's due on Wednesday?
Yeah, we're going to talk about that after 1B. Well, let's talk about that now.
Yeah, I'm working on it right now, and I'm kind of wondering. You mentioned about making a class, but you didn't mention what kind of constructor to make. If that is necessary.
All right, so let's talk about ODP 301. And then when we talk about 1B, that'll take us into try-catch blocks. So ODP 301, you are supposed to create a class named myClass with a single constructor that takes an integer argument and saves it in a variable named x. And so the goal here is I can make a variable in my main program like MC, and it's an object of type myClass, and I construct it by saying new myClass, and I pass an integer. And the goal is, inside the constructor, this value that I pass should be saved in a variable inside this object named x. And I can access that, for example, by saying name of the object .x. So this is kind of like a structure, but we're using a constructor to set the value for that field named x.
So you're saying you want to make a constructor named x so that you know which one I'm talking about?
Your constructor is always named the same as the class. So the constructor in this case is just called myClass. But inside myClass, so you're going to do something like class. You're going to have a public integer named x. And then you're going to make a constructor, and the constructor should take whatever argument is passed to it and just set x equal to that. And that's all your whole class has to do. So that when I call a constructor like myClass17, the code inside that constructor just sets x equal to 17, and now if I were to print out mc.x, it would print a 17. Or if I say mc.x equals 23, this would print out 23. Alright, so make your class, right, which is going to be a separate file called myclass.java. Compile it, and then write a test main program. You could use this as your test main program if you want. This is a perfectly fine one. This should, you know, construct and print out 17, and then this should print out 23. But you can write your own test programs also. And then once you feel like your class is correct, go ahead and assess using this command. So do this from the directory where your myclass.class is, right? And just say assess temp mymain301 myclass.java.
So when I'm writing right now, did you went over like why we or we don't use static as a type method?
Just don't do statics. We might get to talking about the proper use of statics this week. If not, then probably next week. But for everything we do from here on out, other than public static void main, you should not need to use the word static.
Okay.
And if you use it, it will probably take you down a bad path. So just pretend that keyword doesn't even exist except for public static void main. Wow, that's like the most awesome hot chocolate I've had in ages. Alright, someone says PA1B feels like a great chance to work with Git branches. This is true. Yeah, use this as an opportunity to play with Git if you like, because it's pretty friendly once you know the few ways not to annoy it. And someone lost internet. That's a drag. But USB tethering is nice. All right. Let's see. Yeah. So try that, and if you get stuck, ping me in office hours. But it should be pretty straightforward. And so this is, you know, an exercise in making a constructor, and you can see constructors from our sample code. So here's a constructor for the rectangle class. This one happens to take 2 arguments, and what does it do? Well, it saves this first argument in a variable called width, and it saves the second argument in a variable called height. So this is doing, something that ODP 301 wants you to do. It's doing a lot more, actually. It's taking a constructor that packs two integers and stores them in these variables. You only need to store one integer argument in the constructor and store it in a variable called integer x. To compile a file, just say javac space and the full name of the file. To compile two files, say javac and the name of the file twice. Just do the javac command twice. Although a lot of times when you compile one, it will compile the other, but that's okay. You can compile them both by hand. Alright, so this is due Wednesday morning at 8, so try to get it working today and pop in office hours tomorrow if you're getting stuck.
At first I was making a public integer and have return int, but it's just public, right? Just do public and then name of the method.
For the constructor?
Yeah.
Yeah, so constructors are going to be public, the name of the constructor, parentheses, and then the argument list. And it's
typically you don't say what returns. It's just a public, right?
Yeah, and that's the odd thing about constructors. Every other every other method that we write, we specify a type of return, which could be void, or it could be an int or a boolean or whatever. But for constructors, they're the one thing that looks like a method that doesn't specify a return type. So area returns an int, perimeter returns an int, rectangle doesn't return anything, right? It says public, but it doesn't have a return type specified. That's because the name of this thing is the same as the name of the class that makes it a constructor. And so there's never a return parentheses, some value in here. It doesn't return a value of any type. It effectively returns a rectangle, but we don't actually say return, something.
Just out of curiosity, can you does it have to be called? Does the constructor have to be called rec? The same as the class, or can it be different?
If it's not the same as the class, then it's just a method, and if we don't specify a return type, we'll get a compile error. So yeah, the constructor has to have the exact same name as the name of the class.
Okay.
It's kind of a quirky thing, but that's just the way that Java was designed. Instead of having like a separate keyword or something. So yeah, constructors are once you figure out a few of those things about it, then they're not so weird to work with. All right, other questions on the ODP? Hey, welcome. Alright, so yeah, we've been talking about PA1A and ODP 301. And we're about to talk about PA1B. Alright, so here we go with that. So let's take another look at the PDF, which we looked at on Wednesday. So 1B is the same behavior as 1A, except we're actually making a full bona fide Java class named myStack and another class called myQ. And the behaviors of our methods from 1A will get bundled into these classes. And so the whole deal is, instead of saying stack push and passing in a stack and a number, we're just going to use the name of the stack object, period, push the name of the method, parentheses, in this case the one argument we want to pass. And this will push the number onto this stack. And the whole link to working with objects is that, instead of specifying the stack as an argument to a general method that we could pass anything to, the method is actually a piece of the object. And so we say stack.push, that runs the push method inside the stack. We could write a queue.push if we wanted a push behavior for the queue, and that might do something totally different from a stack push. And we could say queue.push, it would be the same name, but which push are we running? Well, it's the one that's part of this object stack. Or we're doing the remove from a queue object, so we would say, the name of the queue.remove. And so here is the spelled out example, right? The isEmpty method in the myStack class tells you if a stack is empty. Which stack is it checking? It's the one that you use to call isEmpty. So bubble_t.isEmpty tells you if this stack, bubble_t, right, if that's empty. In other words, if that linked list inside that class has length 0. And so this is an exercise in repackaging what you've already done, and breaking it into the structure of classes. So you can look at that rectangle class for examples, because that's got constructors and methods and variables or fields defined within the class. And if you understand how to structure that, this assignment takes very little time to write. But the whole goal and the whole challenge is figuring out how to structure that. And that might take, considerable amount of time. But, come by office hours. If it's not clicking, come in, show me what you got, and let's work from there. And please, please, please don't leave this till Thursday afternoon, right? I don't have office hours Thursday afternoon. Get this done today, and then you got the whole week free without, worrying about PA1. Just my suggestion.
Shows how we link the files to the, what's it called, to the main class. Like the myStack and myQ files.
How we do what with them?
How we link those files, like there's like the myStack and the myQ class are in their own file.
Yeah, you don't actually have to link them. So just Java C mystack.java. Java C myQ.java. Java C PA1B.java. And then to run it, just say Java PA1B. So this would explicitly compile your myStack class, your myQ class, and your main class. And in practice, you don't even have to do these. If you just do this, it should compile everything. But since you're developing myStack, just try this, and if you got errors, you'll see those right away. And you don't need a main class PA1B, and you don't need your Q class. You can just develop this on its own and make sure it compiles. And do that first, because if you have some misunderstanding about making constructors, why create two files with that misunderstanding that you need to debug, right? Just work on your stack. Just make a myStack, and in your PA1B, comment out the stuff that calls the Q code, right? And just make a simplified PA1B that just does stacks. And so just get this to compile, and then try calling it, or just make some separate test code. Don't even bother with the input parsing. Write a main program that constructs a stack, adds a few things to it, prints it out, does a pop, and if that works, you're probably good to go. And then once you know how to make the stack, now go ahead and make the queue, and that'll probably work first time once you know how to do it for the stack, and then modify PA1A, the main method, to use these classes. So that would be one way to go about it. All right, other questions?
got a question about code P 301,
Okay.
where apparently when passing a value, how do I capture that? How do I get that value into my class? When passing like 17, an example.
Well, when you call the constructor, if you say, you know, new my class parentheses 17, in the constructor, if you specified an argument, then that 17 will be in that argument.
It's kind of weird because it doesn't seem to be actually calling my class.
So again, if we look at the rectangle example, when I let's go to a better one. When I say rectangle, new rectangle parentheses 2, right? I'm calling the constructor rect with an argument of 2. And so what's the behavior after I make that call? Well, if we look at the constructor, which here's a constructor that takes a single argument. Well, inside this chunk of code, the variable len would be equal to 2 in that case. And so this will set width equal to 2 and height equal to 2. And those are just integers defined here in the top of the class.
That's what I did, but it doesn't seem to work.
Let me take a quick look.
I did make a public my class as a constructor, but and I also put in some kind of integer with the value. I just called it pass value as a variable, and then have that equals x inside the constructor.
Interesting.
I mean, I can go by office hours. I think if office hours on Tuesday.
Tuesday mornings, yeah. So
Yeah, I can come by Tuesday morning, I think.
So let me. This is something that I see pop up with a number of codes sometimes. If I say A equals B, this says copy B into A. Make sure you haven't switched those around. If I want to set A equal to the current value of B, I do A equals B. This will copy B into A. It does not copy A into B. So I think of an equal sign as saying, you know, A is given the value of B. And double check your code where you use past value in X. Got it?
Yeah, I got the equal sign switched around.
Cool. Okay. Yeah, that happens a fair amount.
It gets pretty annoying in the long run.
Yeah, and there's no reason that this means this instead of the other. It's just kind of what it means. I was lucky. The first programming language I used was on a programmable calculator, and it actually had an arrow key that you used for assignment. And so you would write things like that. And so that got ingrained in my brain from the beginning. All right. Any other questions? So let's go on to this important addition. Which is this business of handling illegal integers. So the one functional behavior that changes in PA1B is if you type an illegal integer, you should not simply throw an error and exit. You want to actually catch that and handle it gracefully so that the user is told, you know, oh, this is an illegal integer. Learn to type better or something like that. So let's play with that.
before we start talking about types and catching?
Yep.
Okay, I'm ready to take notes on that one.
All right, so let's read some input and convert it to integers and print out twice whatever the user types in. So so I'm going to have to do an import. And I'm going to make a scanner. I'm going to call it standard in because that's where I'm reading from. And I guess I'll be polite and I'll prompt the user. So I'll ask the user to enter a number. I'll read a line of input from the user. I'll save that in a string input. And let's convert this to an integer. Yeah, go ahead.
Your y in system.out.print is capitalized.
Thank you. So I'm going to do integer.parseInt on this input line. And then I'll just print, one of our smarmy messages, number squared equals, and I'll print out number squared. And then I'll repeat my prompt. And there's the end of that. All right, so basic, scanner demonstration code. Nothing too surprising there. So let's get this running first. So enter a number, 23. 23 squared is 259. Negative 12 squared is 144. 0 squared is 0. And if I type in something that's not a legal integer, this kind of like gets upset at me. And it says exception in thread main, Java language number format exception for input string ha. So it doesn't like trying to convert that to an integer. So it's complaining about line 18 in main.java. So if I go to line 18, it's right here where I'm calling parseInt. And you can actually see a bit of the traceback inside the integer.parseInt method, which is at line 615 of integer.java. It made a call to something else, and at line 580 of integer.java, it threw an exception. And so we're getting this error message from line 65 of number format exception.java. Well, these are not files that I wrote. These are not files that are sitting in my directory, but these are files that somebody wrote to do integer.parseInt. And guess what? It's written in Java, right? This is a class. And you can find the source code for the integer class. It's a file called integer.java, and if you look at line 615, that's inside the method parseInt. And it's at the point where in trying to convert a string into an integer, it encountered something and said, I can't turn that into an integer. No matter what comes after this, this is not a valid integer. And so it makes some calls to a method in this number format exception class, which causes this error message to appear in the program to exit. All right, so this blows up if we put in a bad string. And so there's a mechanism we can use called a try-catch mechanism that will let us capture the fact that an exception is occurring and do something of our own choosing instead of just exiting. So what is an exception, first of all? An exception is, it's kind of like an interrupt. If you've done Engineering 270, it's like an interrupt, an int 0, int 1, int 2, but it's generated by software instead of, by putting a voltage on pin 18 of your PIC chip. Something happens in software, and it says, hold everything, stop what you're doing. Let's run this other chunk of code, which is, in this number format exception class. And this other chunk of code will print out all of this stuff and then cause the program to exit. And exceptions indicate an exceptional or unexpected condition. So if you overflow the boundaries of an array, if you divide by 0, if you try to dereference null, if you try to convert something that's not an integer into an integer, all of these things can generate exceptions. And if you look in the Java documentation, for example, in the string method, if you look at, integer method, if you look at the parse int, it will tell you at the bottom of the description, hey, this could throw, which means cause, an exception of this type, number format exception, if the string is not a parsable integer. And so lots of things can cause these exceptional or unexpected behaviors. And they're usually documented, right? Anytime something can cause one of these errors, it's in a section called throws. This is part of what I've asked you to document when you're writing functions yourself, and I ask you to put a comment block in the beginning of the function. What should that comment block entail? Well, it should describe what the function does. It should say what the arguments to the function are. It should say what the return value from the function is. And it should list anything unusual that could happen. For example, in your stack pop method right now, I said don't worry about what happens if this is called when the stack is empty. So that could cause an exception, right? If you try to pop from an empty stack, you could say, that throws an error. And what does it do? Well, since we didn't write code to handle that, it will just call some default behavior, which is what happens when you pop from an empty linked list. But you could, print out a message of your own, you could throw your own exception, and so on. So exceptions are unusual, unexpected, exceptional behaviors. And so we can make this try-catch block to catch these unexpected situations and process them in a reasonable way. So let's make a new version of this. All right, so we're going to convert an input to an integer. So if the input does not represent a legal integer, this statement would fail. So let's catch that error. Okay, so here's how we do a try-catch block. We use the keyword try. So everything inside this block is going to be attempted. Alright, here's the basic setup. So we're going to say try, and we're going to put a statement inside this try block which says, hey, let's take our input, let's parse it as an integer, and save the result in number. If that statement fails, if anything in this try block fails, we will jump down and we will execute what's inside this catch block. So it's kind of like, you know, do what's inside here. If this works fine, just come down here and continue our code. But if something goes wrong in here, come down here and execute whatever we find in our catch block. And so in our catch block, I'll put in something here. Some useful friendly error message. And we'll just exit out. Alright, so you got the basic mechanism down. Try, everything inside here gets executed. If it succeeds, the catch block is ignored and we just continue with our code. So as long as the person types an integer, we'll convert it to a number, everything runs as usual. But if this statement fails, instead of printing out a message on the screen with an exception and giving up, we will jump into this catch block, which in our case will print a friendly message and then just exit.
You made a little mistake where you put a bracket in the exception argument.
Thank you.
Yeah. So exception, does it have to be called exception as a way of like to catch what kind of error it is?
So let me answer that in a minute. This could be something other than exception, but if we make this exception with an uppercase E, this will always work. But we'll drill into that shortly.
Okay.
Alright, so let me do this. Alright, so if I try to compile this, I'm going to get one error. Right, I'll get this this message about cannot find symbol number, and this is coming at line 30. And so I'm asking it to print out my number, and I'm declaring my number here. So this has to do with what's called scoping, right? When you define a variable, when you declare a variable by saying int variable, string variable, that kind of thing, there's always some notion of scope. In what part of your program does that variable exist? And so, for example, you know, this main method exists inside this class main too, but not outside that. In our rectangle class, the area method existed inside that class, but not outside. Well, when you have curly brackets like this, and I define a variable inside there, the scope of that variable is only inside these curly brackets. So even though I clearly say, you know, I'm declaring number to be an integer, once I leave this curly bracket, number doesn't exist anymore. And so when I get down here, number hasn't been declared. So the easy way to deal with that is just declare this up here outside of that block. And then in here I'm just going to say number equals. So now I'm declaring it at what scope, within the scope of public static void main. So everything in my main program between here and here has access to number. Actually, everything from this point down has access to number. And so this statement here will work fine. This statement here will work fine. And when you add try-catch blocks to code you've already written, a lot of times we have declarations that'll need to get moved outside of that block. So now if we compile this, it should run fine. And so I can type in a number 2, 3, 4, and if I type in something that's not an integer, instead of giving me all that big Java generated output, it just says fool and it exits. Right? So it detected that something went wrong and ran my code and then kicked out. Alright, so if I wanted, instead of doing this, I could say continue. So if we get an error, I'll say fool, I'll ask you to enter a number. I'll say enter a valid number. And I'll do a continue, which will bring me back to the top of my while loop. And so if I run this, we got to do this. Got to name the class the same thing as the file. So 2 squared is 4, 6 squared is 36. If I say ha, it says fool, enter a valid number. If I just hit enter, that's not a valid number. Enter a valid number. Okay, 99. 99 squared is 9801. So now we've got a pretty well behaved program, right? It's kind of impervious to, you know, user error. And all it takes is this one try block, right? Just throw this inside a try. If it succeeds, everything works as before. But if something goes wrong, it gives us an error. All right, so let's modify this a little further, and let's look at this notion of exception. And let's go back to the integer class. And let's look at parseInt. So parseInt says it can throw a number format exception. And that's a class in Java.language. So what is the number format exception? It's an illegal argument exception, which is a runtime exception, which is an exception, which is a throwable, which is an object. So this is a hierarchy of classes. We're going to talk about this more in a few weeks. But a lot of classes are made by extending other classes, by adding or changing things about a base class to create a superclass. And so a number format exception is the thing that you get when you try to parse a non-integer, but it's actually a type of what's just called an exception. And an exception is sort of the most general exception, the thing that can happen when an error occurs. And so in our try catch block, we say catch parentheses exception. It means anything that occurs, any error that occurs that is of a type of an exception, which would include an exception or a runtime exception or an illegal argument or a number format exception. Anything that occurs of those types will match this type of parameter, and so this catch block will be executed. And we can have multiple catch blocks. We could have a catch block that says, hey, if you get a runtime exception, do this. If you get an illegal argument exception, do that. And so if we say, you know, let's catch a number format exception. Right? Well, when we typed a hello and we tried to do this parsing, it generated a number format exception, and it found a catch block that matches that. And so it went ahead and executed these statements. But if we have some different kind of exception,
What does the E represent in that argument?
E is a object, and we'll look at that in a second.
It's like that's a little too far ahead, huh?
You're exactly one step ahead of me, which is awesome.
Okay.
So suppose I say let's catch an IO exception, which is another type of exception. Oh, I just need an exception here. Let's just do this. See if that works. Right, so now I've said if you get a null pointer exception, then let's go ahead and use this catch block. Well, if I type in something that's not an integer, that's not a null pointer exception. And so it tried to find a catch block that said, hey, if you throw a number format exception or a general exception or something else, let's do what's in here. But all I specified was what to do if you get a null pointer exception. And so it did not find a catch block that corresponded to the exception that occurred, and so it did its default behavior of printing out the usual error messages and then giving up. So more often than not, this is just exception. But if there was a possibility that 3 different types of errors could occur, you could have a separate catch blocks for each possible error. You could say if it's a null pointer exception, if it's an array out of bounds exception, if it's a number format exception, you can specify all these different blocks. Alright, so this E is kind of like an argument to the catch block. We can almost think of it as kind of like a function call, except it's not a call, there's no return. But when an exception occurs, we come down and we execute this body of code, and what we're saying is, hey, this should be called if an exception occurred, and if an exception occurred, pass that exception in this variable, this object called E. And so inside here, E will be an object representing an exception. And I mean, we can call this thing anything that we want. It's really just the name of an object. And so usually you just see it represented as an E, but it's just the name of some object of type exception. And so what is an exception? Well, it's all of this stuff. But it's got some methods. In particular, it has a toString method, right? So we could concatenate it to a string and print it out. It's also got a method called print stack trace, get stack trace, get message, get localized message, fill in stack trace, and so on and so forth. Print stack trace is a method which says print this throwable and it's backtraced to the specified print writer, or to the default output if we don't specify an argument. So we can do some things with this EE. So when we get an error, let's say fool, let's print out this object E inside angle brackets so we can see exactly what it looks like. So let's compile this. And let's print an error. And so now E is equal to the string Java language number format for input string ha. So not only can we catch errors and keep our program from giving up, but we can run a piece of custom code, and in that code we can see exactly what the error was that caused us to come down here. In this case, it was this Java language number format exception. And if we have an object, it comes with methods. And one of those methods is called print stack trace. And so I'm going to print out that stack trace, and I'm going to put some tags in the beginning and end so I can see exactly what the context of that is. And then I'll ask for a valid number. And so let's compile this. Alright, now if I type in an illegal int, it tells me fool. It prints out the value of my exception object, which is this nice, string that tells me exactly what the error was. And then I can print out the stack trace, and the print stack trace method prints out all of this stuff. Right, so it repeats the error itself, and then it shows me the reverse call frames of what led to the exception. Bless you. So starting with line 25 in main4.java, it called parseInt, and at line 615 it called something, and at line 580 it called something else, and in that thing at line 65 it threw an exception. And so yeah, you can make a switch of different exception types to handle different errors differently, exactly. Alright, so this is way more than you need for PA1B. PA1B, all you're required to do is, before you parse the integer that the person typed in to add to the stack or the queue, make sure it's legal. So you're just going to need a try catch block, right? Do your parseInt, and if it fails, you can just print a message saying, illegal integer, and then just continue on your merry way. But for other situations, if you needed to do more processing based on what kind of error occurred, right? You can have multiple catch blocks. You can dig into the details of this exception. You can print the stack trace and so on and so forth. And this e.print stack trace generates all of this output. Let me see. There's also a method called get stack trace. So get stack trace will return an array of what are called stack trace elements, and each stack trace element represents one stack frame. So I could actually use e.getStackTrace, and I could get an array that would contain probably 4 elements corresponding to each of these 4 lines. And so if you need to do something like, inside your code, know exactly what line caused the exception or something like that, you could grab the stack trace in an object and start parsing it, right? So there's all kinds of possibilities. And it goes along with this idea that everything is an object, right? Even your exceptions, your errors that occur, those are objects. And they come with methods that will let you do things like, you know, pull out the stack trace or get the actual error message. So if I say get message, that returns a string. And so I could instead of printing out the error like this, I could, you know, do e.getMessage and then do some analysis on it, parse it and see if it contains this word or that word. This is part of what you get with an interpreted language. These things are harder to do with compiled languages, but with an interpreted language, right, the architecture of the machine our code is running on, the Java virtual machine, supports all of these behaviors. So we have, you know, all this ability to interact with low-level things such as exceptions that normally are, you know, kind of outside our control. All right, the last thing is the always block. Sorry. Finally block. It's like an always block. So if you have a try catch, right? So let me make a 5th version of this. And let's get rid of some of this. Alright, so here's what a finally block does. It lets us specify that should be something that should happen whether we succeed in the try or we end up in a catch block. We should always go ahead and execute this finally block. So if we type in a valid integer, 2 squared equals 4. Well, that's weird. Oh, no, that's right. It did it. All right. So if I type in a valid integer like 2, it says it entered the finally block. Right? It didn't do anything. We tried to convert the string 2 into an integer. That succeeded, so it did not execute anything in the catch. It executed the finally block, which said in the finally block. And then our code continued and it printed out 2 squared equals 4. And so if you type a valid integer, it will execute the finally block and then say -1 squared equals 1. Now if I type something illegal, like hello, it says fool, it says enter a valid number, and then it says in the finally block. So what happened when I typed hello? It tried to parse hello as an integer. That caused an exception. It jumped down to the catch block. It said fool, it said enter a valid number, and then it said continue, which should go back to the top of the loop. But before it did that, before it gave up on the catch block, it came down and it executed the finally block. And it said in the finally block. And then it went back and did this continue, and so now I'm back up at the top of my loop, and if I type in a number, it prints out its square. So this is one of the things I find kind of quirky about Java. So if no error occurs in the try block, you skip the catch block, you execute the finally block. But if an error occurs in the try block, you will jump down and you'll execute the catch block, and then you'll jump down and execute the finally block. So no error. You start in the try block and then you just jump down to the finally block. But if there's an error, you start off in the try block, you jump to the catch, and then you jump to the finally. And the weird thing is, even if your catch block says something like return or continue or something like that, you'll still execute the finally block before you leave the catch block. That's just a little weird. So the behavior here is if something goes wrong, we'll come down to catch, we'll print out these messages, we'll jump into the finally block, say in the finally block, and then we'll do our continue up here and go back to the top of the loop. I've never actually used a finally block in coding Java. Doesn't mean they're not useful. I just have found ways to not have to use them. But if you do have to use them, just be aware of that. They always get executed, even if your catch block or your try block says something like continue. Alright, so that's kind of a full rundown on try-catch blocks. Like I say, the amount of this you need for PA 1B is really small. It's just a single try statement and then a catch statement that says something like illegal integer and continue. The other thing I'm going to say is keep these blocks as small as possible. If you have 100 lines of code and an exception could occur in there, do not put all 100 lines in a try block, right? That's considered really bad coding design. Put your try block exactly around the one statement that could cause an exception. If you have two statements in a row that could cause an exception, it's the same type of exception, you can put them both in the try block. But if I've got some code and then here's a statement that might cause an exception, and here's some code and here's a statement that might cause an exception, right? Don't put this all inside one big try catch. It's really bad design, it's really lazy. It's considered a poor way to do this. Put a try catch block here, put a try catch block here, put a try catch block here. You can't see what I'm pointing at. Okay. Yeah. Bunch of statements, possible exception, bunch of statements, possible exception. Don't put the try catch around everything. Put a try catch here and here and here. Alright, that's pretty critical. Because, you know, a try catch is saying if anything goes wrong, jump down to the exception. Well, if you have 100 lines of code and any error anywhere in there is going to bring you down to this catch block, right? Well, you don't necessarily know what caused the error, and so how do you know how to respond to that? And I say this extra passionately because this morning I was going back through some old code that I wrote about 15 years ago, and I was trying to figure out why it wasn't working, and I realized that I was inside a try-catch block, and that try-catch block was 700 lines long. And so I had 700 lines of Java surrounded by the keyword try, and if anything went wrong anywhere in there, it came down to catch. And I have no earthly idea what's causing it to come down to that catch block. Something in these 700 lines of code. So really bad design. That was my first big Java program. So keep these things as tight as possible. All right, questions on that? All right, let's do a 5-minute break. We will come back and dig into some more stuff. Just try work with flipping a variable, catching if a variable becomes true. No, because becoming true is not an exception, so we can't use it like that. That would be interesting. But yeah, no, that doesn't work like that. All right, so I'll see you back in about 4 minutes. Awesome hot chocolate. Yeah. I didn't think I liked marshmallows, but I do.
Oh yeah, because they melt.
Yeah, totally.
Uh-huh.
Whoa, someone's making the fort.
I know. This may be the first time she's ever had enough snow to actually do something like
Right.
that. Yeah. Oh. It's so cool. Here's my phone. Okay, let me know when you're done. Yes. Yes. You want me to do one in progress here? Or one at the end? Okay. Okay, you ready? Excellent. Okay, thank you. Yes? Yes. Awesome, thank you.
All right, we're back. I was just looking at my emails. I had like 30 emails in the first hour of lecture, and none of them are from like students. All right. Try catch blocks. It is still snowing fabulously. I'm going for a walk after class. Let's talk about main. Alright, so here's a class called mtest. And, you know, even with nothing in the body, it compiles just fine. And if I change the name of my main method to something else, like main, I can still compile this. So I don't technically need to have a method named main. But if I try to run this, I will get an error. And the error is main method not found in class mtest. And it even says, please define the main as public static void main string bracket bracket args. So I can make a class that does not contain a main method. In fact, we're going to do that. The myStack class will not contain a main method. The myQ class will not contain a main method. The rectangle class from last week did not contain a main method. But somewhere, if we're making an executable program, there has to be a class containing a main method. And the name of that class, that's what we specify when we say Java. So if I call this thing just plain old main, and I compile it and I run it, now it runs just fine. And it doesn't do anything, right? But, you know, we could put a print message in there, and now it does what we expect. So what if I make this instead of void, I say this is an integer method? Well, that'll compile just fine too. Oh, except that I forgot to return something. Right? That compiles just fine. But if I try to execute it again, I get the message saying there's no main method. To be a main method, it has to return a void. Please define the main method as public static void main. This is a method that happens to have the same name, but guess what? A different signature. It's a method that returns an integer. That's different from a method that returns a void. So this has to be void. If I make a method named main that happens to take a second argument named x, that'll compile just fine. But when I try to run it, again it says main method not found. Please define the main as public static void main string bracket bracket args. Different signature. The signature is the name plus the types of arguments. Well, this is a main that expects 2 arguments. That's not the main, that's the main program. Right? The actual main method is supposed to be called main, take a single argument, which is an array of strings. So I can't do that. If I declare this as taking a single string instead of an array of strings, compiles fine, does not execute. Alright, what about this? Is this going to work? Make a vote. There's only 8 people. Your vote counts. Is this going to work, or is it going to give me an error?
No.
No. 1 vote, that's going to be the decider.
Come on, guys, don't leave me hanging.
Get out and vote, man. Rock the vote. Your vote counts. All of that stuff. Alright, we got 1 vote for no. We'll run with that. This will compile just fine. This will actually run just fine. Because the signature does not depend on what we call these variables. The signature is the name of the method and the types of variables. So even though this says, you know, declare it as public static void main string bracket bracket args, we can call this argument anything we want, and it still matches the signature. But almost always you'll see this called args, which is short for arguments. But in fact, this is perfectly legal. but we were democratic anyway, so that's good. So yeah, signatures is the name and the types of arguments. All right, so what is this argument that we pass in? Let's just take a look at it. Let's print out args inside angle brackets. Well, it runs and args is equal to ljava.language.string semicolon some hexadecimal number. Well, that's not very exciting. And if I say, you know, Java mtest, this is a test, it still just says, you know, it's equal to, turn out to be the same hexadecimal number as before. Well, it's an object, right? Everything's an object. But let's take this as an array. So arrays are a real thing in Java. And generally we can declare an array by doing something like, you know, string data equals new string bracket 10. Well, this declares data to be an array of strings. This constructs the array of strings. It does the equivalent of malloc to actually create space and memory for 10 strings. And after we do this, we could say data bracket 3, this is a string. We can say data bracket 0, this is a string. We can say data bracket 9, this is a string. If we try to say data bracket 10, that will throw an exception. So let's take a look at this. Instead of just printing out all of args, let's look at args bracket 0. Let's print out args bracket 0 equals, and let's compile this and let's run mtest. Oh, didn't expect that. Compile it and then run it. And guess what? Args bracket 0 is the string this. Why is it this? Because I put the word this after the name of the class that I wanted to run. So args bracket 0 is actually the first command line argument after I said Java mtest. If I print out args bracket 1, guess what? Args bracket 1 is the word is. So I can do this. So this is how we pick up command line arguments. And it's a lot sort of more natural here than it was in C. If I say Java, which says, you know, run the Java virtual machine to execute the main method in a class. Here's the name of the class I want to use. And then I put some extra things after this, separated by spaces. I can get those from inside my code as elements of this array of strings. And because strings are a type in Java, we don't have to worry about char stars or char star stars because we have arrays. And this is just an array of strings. And we can say that variable name bracket 0, 1, 2, 3 to get the 0, first, second, or third name. And what if I go too far? Right, I'll get an exception. When I tried to print element 4 of this array, I got an exception, array index out of bounds exception, at line 9, which is right here. Line 9. Alright, so how do we avoid getting that exception? This is not where you want to use a try-catch block. You could, but that's kind of sloppy. Right? That's overkill. So with arrays, we have a way in Java to tell how big the array is. And it's a field in an array called length. And it's not a method. It's not like getting the length of a string by saying string name.length paren. It's a field inside an array. And so let's let me start a new one. Let's call this mtest2. Alright, so arrayname.length tells you how many elements are in the array. So if I say Java mtest2, this is fun, args.length equals 3. Why? This is fun. 3 arguments. Right? If I put 7 arguments, then args.length is equal to 7. Linux thing, if I embed that inside quotation marks, it's a single argument. These spaces aren't separating it into separate arguments. Because I have quotation marks, this whole thing is one argument. If I do this, this is 3 arguments. The first argument is this quoted string with all of this space in there. The second argument is cool. The third argument is by. That's like standard Unix behavior, right? If I run it with no arguments, args.length is 0. Simplest way in the world to know you have no arguments, check the length of this arguments array. If it's 0, there's no arguments. So let's print out the arguments just because we can. So I'm going to make a loop. I'm going to loop from 0 up to args length minus 1. I'm going to print out args bracket, that index equals angle bracket, the value of that element, and then a closing angle bracket. And so this is like when we were playing with argc, argv in 224. One of our first examples in class was just to write some code to look at the elements of the argv array, and we looped over argc as our upper index. But it's a little simpler in here. So if I say Java mtest2, this is fun, right? Args bracket 0 is this, 1 is, 2 is fun. Length is equal to 3. If I do this, you know, where I had a bunch of spaces, but I put it inside quotation marks, all of this became argument 1. Well, we can see that right here. First argument is this thing, Second argument is cool, third is by. And if we don't have any arguments, then it didn't print out anything. It should print out length equals 0, and then our loop doesn't print anything. So as we move to writing programs where we're processing command line arguments, right, this is the mechanism you'll be using. And it's a whole lot easier than it was in C. It's a whole lot more straightforward. And remember, this is not a method, right? args.length is not something like this. Right, if I try to do that, I'm going to get compile errors. Right, because there's no method named length defined for an array of strings. It's a field within this object named args, which is an array of strings. All right, questions about that?
Do we still need to verify the size of the arguments before calling to them like in C?
Sure. If I didn't know if there was a command line argument or not, and so yeah, let's say you're writing a Java program, and you can either just run it with the name of the program and have some, you know, size, high, low, or hash table size or something, default to 100, or you can say main and specify the size on the command line, right? So I might want to say main and use a size of 100. I might want to say main 50 and use a size of 50. So if I'm trying to parse this, right, I don't want to start trying to convert, you know, args bracket 0 to an integer if args bracket 0 doesn't exist. If I try to convert args bracket 0 to an integer and the program was run like this, I'm going to get an out of bounds exception saying, hey, there is no args bracket 0. So before I could do anything with this, I would want to check args.length. If args.length is 0, I know the person did this. I don't want to try to do something with, you know, an element in the array that doesn't exist. So as usual, the order in which we do our checking has to be logical, right? Don't check something about args bracket 5 if you don't know that there's an args bracket 5 to check. So check your args.length and make sure it's at least 6 in that case. And if you try to do something with this and it doesn't exist, you're going to get a probably out of bounds exception. Does that make sense?
That makes sense.
Cool. All right. So this is a little bit about arrays in general. Again, we can define an array, say, of integers. If we do something like this, x will be an array of 20 integers. We could pass x to a method or do something else with it, and at some point, if we want to know how big the array is, we can always say x.length, and that should give us 20 in this case. And then if we wanted to add up the elements in this array and take their average, we could just add up all the elements and then divide by x.length. And we can declare X to be an array of integers like this. And then we can do, you know, some code. And at some point we can construct using the new keyword. And this could be an integer, or, you know, it could be a variable or some expression that evaluates to an integer. And again, it's kind of like malloc, right? It's kind of like mallocing size of int times something, right? As long as this evaluates to an integer, this will construct an array containing that many integers, and it'll set X to be a reference to that. So if we know how big our array should be, we can construct it in the same line as the declaration, or we can declare it in one spot and then construct it later on when we know how big we want it to be. And at any point we can access the length field of whatever the name of the array is and see how many elements are in that array. All right, let's talk about private versus public. And this notion of protecting areas in a class. So let's play with some sample code. So we'll have a public main, or a public private main. And let's just play with our rectangle class again. So we'll make a rectangle class. Alright, and make a really simple class. No constructor, no methods. It's just a kind of wrapper for holding two integers, height and a width. And so I'm going to construct a rectangle here, and I'm going to say r dot height equals 12, r dot width equals 10. I'll just do the height. Alright, so I construct a rectangle, I'll set its width equal to 10, I'll print out its width. Right? Not a big surprise there. So we set the width to 10, we printed out the width, it came out to be 10. And you know, when I compiled my pmain, it also compiled my rectangle class and gave me a rectangle.class file. So it compiles stuff as needed. So let's tweak this a little. Suppose I say private integer height comma width. Well, now when I try to compile, I'm going to get an error message. And it says width has private access in rectangle. And so trying to say r dot width is giving me an error. And similarly, when I try to read r dot width, I get the same error, width has private access. So this variable width is now hidden from my main program. I've constructed a rectangle, but I have no way to get to this field. And so this is something we might do, for example, when we made our linked list package. We had a sentinel node inside the linked list. And I warned you that your main program should never tinker with that sentinel. Right? We should never look at the sentinel's data value or look at the next value or start following the links or things like that. That sentinel is not part of the abstract notion of a linked list. It's part of the implementation that we created for a linked list. Well, we could make that sentinel private in a linked list class, And then there'd be no way that a main program could say, you know, mylist.sentinel. It would get an error saying, hey, private access. So we can use this private keyword to basically hide information from the user, from the caller. And all this time that we talk about these things, when I talk about the user, right, I'm not talking about, you know, we're the programmer and we're going to create code for the user and it's an us versus them kind of situation, right? Usually I'm talking about us, right? But if you think of a class that you've written and then you think of a method that's constructing objects of that class, right? That's kind of the us versus them. Even though we're the programmer, we're writing all of this code, right? But this is the stuff that makes up the rectangle class. And this is the code that's using that rectangle class. And the idea is to be able to hide certain aspects of this class from the code that's using that class. Right? So it's not like a security thing, like we're writing a class and we want to keep information secret so nobody can discover it. It's about reducing the possibility that we might do something in here that corrupts our data structure, for example. By, you know, for example, monkeying with the sentinel node or playing with the next fields of our nodes in a linked list. Or possibly by coming in and doing something goofy like setting the width of the rectangle to be negative, which would give us a negative area which might cause a math exception somewhere. So this is generally called information hiding, and it's one of kind of the two pillars of object-oriented programming. So information hiding and encapsulation. Encapsulation is bundling code and data. Information hiding is basically preserving this firewall caller and implementation, and the caller interacts with the data structure through some sort of interface, a set of methods. Alright, so the height and width are private here. Well, if the height and width are private, how can our main method do anything with the rectangle? And the answer is we do it through methods. And so we usually create pairs of methods called accessors and mutators. And these are ways that we can control a main or an outside caller's access to private fields in a class. So let's make some accessors and mutators. And this is a concept that will come up again and again. And we're just going to play with width. All right, there's a mutator. This is a method. The method is public. And if someone calls the setWidth method with an argument of w, the width field of this class will be changed to w. Even though width is private, this method has access to it because it's defined inside the class. So now if our main program wants to do r.width equals 10, we're going to do it like this. We're going to call the setWidth method with a value of 10. And what is setWidth going to do? It's going to say, hey, take the argument 10, set width equal to that. So this call to setWidth does the same thing as saying r.width equals 10, except, guess what? It's being managed by this method inside the rectangle class. Alright, same thing with reading the width. Instead of using the field directly, we're going to use a method called getWidth. And getWidth will simply return the width. So let's make a an accessor. And so now we've got a method. The method is public, so we can run it from outside. We can call getWidth. We don't pass it any arguments, but it returns the width field. This method can get to the width field even though it's marked as private because it's inside the same class as the width field. So yeah, this is ADTs coming back at us. So now if we compile pmain, we get even more errors. So it's got to say void if it's void. Alright, we compile pmain, and if we run it, hey, we've managed to set the width to 10. Alright, so you might be at this point saying, like, you know, what the heck, why are we doing this? Why not just say r.width equals 10? We're trying to control access to this. And for example, maybe we don't want to let the user define a rectangle with a width of 0, or a width that's negative. Well, if the width field is public, there's nothing to stop the user from saying r.width equals -1. And that might do something really bad. We might try to compute the area, and the area could be negative. And then at some point, if we tried to take the square root of the area, or the logarithm of the area, we'd get an exception. And maybe to us, for our definition of a rectangle, it makes no sense to have a rectangle with a negative area, or an area of 0. Well, if we let them have access to the width field, they can say r.width equals -1. So here's what we're going to do. We're going to put something in here, and we're going to say if width is less than or equal to 0, we're just going to silently ignore their request. And so now if we say let's change the width to -1 and print out the width. Well, we didn't expect that. If w is less than or equal to 0. Alright, so we're going to set the width to 10, print it out, then we're going to set the width to -1 and print it out. Well, guess what? When we set the width to 10, it printed out 10. When we tried to set the width to -1, our mutator ignored that. And it said, hey, I'm not going to let you specify negative width, and so the width is still 10, even though we said set it to -1. So we've got control over what we consider to be a legal width. And we could print an error message here if we wanted and say, you know, widths have to be non-negative. Or we could give it a default width of 1 if that's the smallest width we want, or whatever we want to do, right? But the point is we have control over how the user is going to modify this field called width. Because they're not just accessing the field and setting it equal with an assignment statement. They have to go through our method, our mutator called setWidth. And you can do all kinds of things with this. For example, maybe I'm going to store my rectangle dimensions in millimeters. And maybe I'm telling the user you can set the dimensions in inches. And so when they say they want to set the width to 1, maybe I multiply that by 25.4 and I store my width of 25.4. And when they ask me for a width, I take this width and I divide by 25.4 to give them a width in inches. And so in my class, my rectangle class, I'm storing in units of millimeters. Maybe that's what makes the most sense to me. But when the user wants to know the dimensions of the rectangle, they call this accessor get width, and it gives it them the width in inches. And then if I decide later on I'm going to store my rectangle dimensions in mils, which is 1/1000th of an inch, I can change my code and I can still set it up so that get width returns inches, and set width takes a value and treats it as inches. And the user's code does not change. They don't need to convert their code from inches to mils or something else. The implementation changes. And by making these things private, the user's not able to come in and directly interact with these. Now, if the user came in and directly set the width equal to 254 to say 1 inch, or 25.4, and then I change my internal system to use mils, 25.4 is no longer an inch. So we're controlling the interface between the caller of our methods and the implementation of those methods, right? This is abstract data types. All right, so I'm going to call that good for now. So work on PA 1B, work on the ODP, come by office hours if you've got questions. And Thursday or Wednesday, let's start making some more interesting classes. Let's make a linked list class from the ground up. And this will give us another example of playing with classes, but using it for some of the data types that we worked with in 222, starting with a linked list. All right, so have a good afternoon, stay safe, and I will see everybody next time.